Greetings of the day to everyone, and today we'll be learning a very interesting topic in the physics realm, that is thermodynamics. First of all, what you have to understand about the term thermodynamics is that it is derived from two words, thermo and dynamics. The word thermo means temperature related, and dynamics means the change, just like rotational dynamics and something like that. So, this is a basic intro of what we are going to learn today. And now let's start diving deeper into it. Now, let us first understand some of the basic uh, thermodynamical terms that we are going to use in this chapter. So, I'll write thermodynamic terms. And the thermodynamic terms, in these terms, there are some basic terms which we already know, which include some obvious terms like temperature, which is denoted by T. Then the second one is V, that is volume. Then the third one is pressure. These would be our standard symbols throughout our chapter. Food will be heat or enthalpy, that would be by H. Enthalpy is a good word, a thermodynamic word used for heat. The fifth one would be internal energy, that is potential energy of the system. That is denoted by the letter U. Yes. And something else that you need to know is Gibbs free energy. Yes. And now let us understand one thing, that is types of works. Done. There are two types of works done according to thermodynamics. The first one is mechanical work, and the second one is non-mechanical work. The mechanical work is expressed in the form of P delta V, that is P V2 minus V1, while non-mechanical work is work due to electrical forces and other forces. So this is it, and in this chapter we'll be mostly focusing on this part, so I'm putting it on stars. Let us now understand that P delta V, this equation is going to be our life for thermodynamics. How is this equation derived? Work done is equal to integral of P times dV. So what does this indicate? This is area under PV curve, and now there are some basic sign conventions which we will follow. So if this is our system, Then on this system, if the work is done on it, then work done is positive, and if the heat is given inside, then to Q is positive, but if it is liberated out, then Q is negative. And if work is given out by the system, then it is negative. This is according to the nomenclature of physics, and it may change while going into the chemistry. So please keep a mind of that. So now let us understand some basic formulas. So there are laws of thermodynamics, and there are three laws of thermodynamics, out of which only two we are going to study. So I'm writing those two. So first these three laws, and we are going to study the three of them. One of them is like not majorly counted, but still we'll write the 0th law of thermodynamics. It states that if system A is in equilibrium with system B and system B is in equilibrium with system C, then according to this law, system A would be in equilibrium with system C. This is an obvious point. The next second one is first law of thermodynamics. And this law is delta Q equals to delta U plus delta W. And following the sign conventions, yes, so this is a first law, and as it is a law, the word law itself means it has no proof, it is derived out experimentally. So yes, this is our first law of thermodynamics, which states that the change in the enthalpy would be equal to the summation of change in internal energy and the work done in reaching the final state of the particular system. And now there are certain formulas for delta U, which is NCV delta T. And now you might be wondering what is this CV. So we'll come to that in a moment. And Q has its formula, that is NCP delta T. How are these formulas now derived? Let us understand that. So we know generally that heat is equals to Ms delta T, which is the mass of the substance times the specific heat capacity times the change in temperature. So similarly, we have got all these two formulas. And now what is Cp and Cv? Cp is specific heat at constant pressure, and Cv is specific heat at constant volume. Yes. And now let us know another relation, that is Cp minus Cv is equal to R, and Cp by Cv is equals to gamma. So now again you might be wondering what is this gamma and R. So I'll introduce you to both of them. So let me use another color. This is real gas constant, and this is a constant which we assume for the ratio, and gamma comes out different for different types of gases. Then if it may be a monoatomic gas, then gamma would be different, as Cp would be different and Cv would be different. There is a formula which we would derive, which I would tell right now. So Cv is Fr by 2, then Cp becomes 1 plus F by 2 times R. So if we do Cp by Cv, it becomes Cp by Cv. I'm writing 1 plus F by 2 times R upon F by 2 times R. So this R gets cut, and now it remains 2 by F plus 1 equals to gamma. So this is important, this is important, and this is important. 3 important formulae. And till then, let us understand the types of processes. So the first type of process is quasi-reversible. That is a partially reversible. And with that I mean, if we took a certain amounts of, say, a particular material, a solid, and if we put it in a liquid, and if we put it in a liquid and again we immediately drain it out, it is not salt that we are thinking about, it is some kind of heavy metal that we are putting inside, then there would be some amount of particles that would get collected and others would get dissolved. So this is partially reversible process. This is just for example, this is not an actual partial reversible process. Just for understanding sake we can take it like that. The second is isothermal. And now remember, the word iso means constant, just like isotropic and all. So isothermal means delta T is 0 and temperature is constant. So let us see our work done. It is P delta V, and if we see there is no effect, so work done would not be equal to 0. If we see U, then it would be equal to 0 and Q would also be equal to 0. Why? Because if we see the formula, it has delta T and delta T which is equal to 0. So both these terms will be equal to 0. So seeing our first law, Q equals to U plus W. Therefore, we will not say that Q is equal to 0, as there is another formula for Q at constant temperature, which I would write over here. Uh, 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 mm, 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 mm. Yes, delta Q equals to mass tensor, where L is latent, specific latently. Yes, and now these formulas are important. So we cannot say that this is equal to 0 Q, but U is for sure equal to 0. So Q becomes equals to delta W. And if we go and understand specific heat capacity, then that may be an even, so I'm writing S. Therefore, we have a formula Q equals to ms delta T. So S becomes equals to Q upon m delta T. Now m delta T, delta T is equal to 0. So S becomes 1 by 0, that is infinity. Another graph now I'll be drawing. And then the isothermal expansion you need to know is that isothermal expansion has this particular graph, and isothermal compression has this kind of graph. You can see the compression in this direction. Yes, the arrow mark shows that there is compression, and we are flowing from this side to this side, from this side to this side. That is what the arrow mark is indicating, and over here in expansion we are showing the growth in volume. Yes, and now let us go to our next process. No, before that we will find out the work done, which we concluded was non-zero. So work done in work done in isothermal process, and we know that work done is equal to integration of P dV. Now we know one thing, that temperature is constant, so P into V would be equals to constant. So P would be equals to some constant divided by V. So I am putting that in this equation. Work done will be equal to integration of a constant by V into dV. We know that work done is equals to C integration of 1 by V dot dV, which would be equals to C into log, I'll write limits from V1 to V2 just for generalization, log V from V1 till V2. And this would be dW, so integrating dW would get us this. And now if we substitute values, log of V2 minus log of V1, which can be written as log of V2 by V1. Now we want to remove that constant C. Now we know PV equals to nRT. PV equals to constant, and that constant is equals to nRT. So work done will be equals to nRT ln V2 by V1. or it can be written as nRT ln P1 by P2. Yes, these formulas are important, expecting some kind of questions from it. Now, let us understand the isothermal bulk modulus. What is bulk modulus? Bulk modulus is equals to minus of dp upon dv by v. This is the definition. So bulk modulus represented by K is equals to minus of P by V upon 1 by V. Therefore K becomes equal to P, and we know that the reciprocal of bulk's modulus is compressibility, and no process is perfectly isothermal. After this, now we are moving on with another type of process, that is adiabatic process. For adiabatic process, we need to remember PV to the power gamma is equals to constant, and now that gamma is Cp by Cv as we saw earlier, and adiabatic process is this vast process, and we will continue about adiabatic processes in the next episode. Till then, take care of yourself, keep watching our videos, and do like, share and subscribe. Thank you.